In this video, I'll talk about special products. It's helpful to know about special products to help us form products more quickly if they fit the pattern that we see here in these special products. And the other time that it is beneficial to know about special products is when it comes to factoring, which we will talk about later on. So let's just take a look at a few special products. I'll point out the patterns, and then I'll show you some examples of using them to find products. So notice the first one is the distributive law, and is where we have a binomial multiplied by a coefficient which is outside the bracket. So in that case, we always multiply the coefficient by each term inside the bracket. So a times x plus a times y. The square of a binomial. We have a binomial here, x plus y. When it is multiplied by itself, we end up with, well, we have an x squared on one end, the other end has y squared, and the middle term is 2xy. Now you probably know this from looking at the product formed through the long way. Let's take a look at that. X plus y all squared is x plus y times x plus y. Let's use FOIL and we'll multiply this out. X times x for the first terms, which is x squared. The outside terms, x times y, which is right. So I did x times x and I will do x times y. The inside terms, yx, which is also xy. And the last terms, y times y. So we notice in this case, when we square a binomial, the pattern that happens is we always end up with middle terms that are the same, and they have the same sign, so that is 2xy. And you can see that right here in the formation of the square of a binomial in the pattern. The exact same thing happens with a subtraction in our binomial that is squared, so x minus y all squared produces the middle term being a negative. However, the last term, y squared, is positive because we are doing negative y times negative y, which produces the positive here. Other than that, the pattern is the same. In the next one, we have a product of two binomials. Now these are different binomials. Up here, it was the same thing being multiplied by itself, whereas down here it's x plus a times x plus b. If we go through the same process where we use a FOIL and we multiply it all out, I will multiply the first two terms, x times x, which is x squared. Then I will multiply the outside terms, x times b, which is plus bx. And then I will multiply the inside terms, which is a times x, which is plus ax. And then I will multiply the last terms, a times b. So notice that we have an x squared term, we have a couple of x to the 1 terms, and we have a constant right there. So these are like terms in the middle. They're both multiplied by x, so they simplify to, and if I had a little bit of room, so b plus a all multiplied by x, which gets us the middle term in our special product. Okay? In the next one, the product of a sum and difference. So we have the sum of x plus y and the difference of x plus y, and it always turns out to be x squared minus y squared. Or in other words, we call this one a difference of squares. And later on, we're going to factor a difference of squares. We'll be recognizing them and going back to the factors. And we also have a more elaborate view of that, which is ax plus by multiplied by ax minus by. That's a sum and difference, product of a sum and difference. And so we end up with ax all squared minus by all squared. Now, if you want to write those down, I suggest maybe pause the video and make a note of all of them. Be careful where the positives and the negatives are, and the squares and the x to the 1 power is, because that's significant in the formulas. Now we will look at some examples of using these special products to form products. If you notice that my 5x plus 6, or my 5 multiplied by the quantity x plus 6, fits the pattern of the first special product that we have seen here, where in this pattern a equals 5, x equals, well, x, and y equals 6. So since it fits the pattern, my product is going to be a times x, which is 5 times x, plus a times y, 5 times 6. And it's complete. The next example involves the square of a binomial. Notice that I have a binomial here, x plus 3, and it is getting squared. So it fits the pattern of x plus y all squared. And in this case, my y is equal to 3. Well, let's start with x. X is equal to x. Y is equal to 3. And so therefore, we have everything we need to expand the binomial using the pattern here with these 3 terms. X squared plus 2 times x times y, which is x times 3, plus y squared, which is 3 squared. Let's simplify this. We get x squared plus 6x plus 9. A very similar pattern occurs with this binomial with a difference between the two, x minus y all squared. Well, I'm just going to say here my x is equal to x and my y is equal to 7. And so I will follow the same pattern. X squared minus 2 times x times 7 plus 7 squared, which is x squared minus 14x plus 49. We are doubling the y term and multiplying by x, and then squaring the y term here. In this example, we look at the product of 2 binomials, x plus 9 multiplied by x plus 2. Notice that it fits the pattern of x plus a multiplied by x plus b, where my a equals 9, my b equals 2, and therefore I can follow the pattern of the special product, and it is x squared plus, we'll do b plus a, which is 9 plus 2. I'm going to write it, but you could probably do that in your head, and don't forget that it's multiplied by x. And we do the product of 9 times 2. So that could go on in your head as well. So this is actually x squared plus 11x plus 18. This is actually the product of a sum and a difference of the same value. Notice in the pattern it's x plus y times x minus y. So it has to be the same value in this case. My y is equal to 5. So following the pattern, the first term is x squared. Subtract y squared, which is, we'll write 5 squared first, and it simplifies to x squared minus 25. We actually refer to this as a difference of squares. Because the first term is a square and the second term is a square. And it's a difference in between. In my last example, I have an example that fits the pattern of ax plus by multiplied by ax minus by, another product of a sum and difference. So we can establish that our a is 3, it's multiplied by x, and our b is 6, it's multiplied by y. And so the pattern is that I take my ax and square it all. So we'll do 3x and it gets squared. Subtract 6y and that gets squared. Now remember, when the square is on the outside of brackets, that the square applies to each factor inside the brackets. So I must be squaring like this. So let's see what it looks like. 3 squared is 9, x squared is x squared, subtract 6 squared is 36, and y squared is y squared. Thanks for watching.